Hello and welcome to the 10th and final lesson in Spiral 2. So we're looking at average speed as a rate of change, and I want you to be able to demonstrate how average speed is a specific type of rate of change. So for those that are watching the video, we would have done an investigation if we were in class. So basically you would have came up with or figured out that we're going to draw a couple of graphs here. I'm not sure if this will be, let's start with 4. We'll need a couple more space below, but let's start with 4. So in the investigation in class, you would have found that our motion graph, so this is time and distance in each case. So time, distance, time, distance, time, distance. All right. So the first type of graph you would have discovered is this one, a flat line or horizontal line. And this is no motion. So you're not moving forward or backward. Your distance is always the same from the x-axis. The next one in the investigation would be a line that looks like that. And what this is moving away. So your distance from the x-axis, so this is where you started from your home, is increasing. So moving away at a constant velocity. All right, and because it's constant because it is a straight line like we did in the previous one. It's a linear relationship. So you're moving away and going the same distance away each time. So it's constant. The next one you're looking at is this one here. So now your distance is decreasing. So that means you are moving toward home because it's a line at a constant velocity. All right, so those are your 3 important or key ones for us. The other ones that you would have investigated, you would have ended up with a curve like this. So for this one, again, your distance is increasing. So that means you're moving away. And instead of a constant velocity, it's a curve. So we say moving away, speeding up. Speeding up. All right. And I got a couple more to draw then. So down here, I think there's 3 more after that. And it's all time and distance. Time and distance. Time and distance. If I'm going too quick, make sure you pause the video so you get everything written down. So your other graph would look like this. All right. And in this particular one, curves down. So in each case, your distance is decreasing. So you're moving toward, call it home, and speeding up. So that means that you started out slow. Now you're running faster and faster as you get toward home. The other one then would look like this. Curve that looks like that. So you're starting out really fast, but when you get way out here, it's flattening out. So you're slowing down. So you're moving away, and slowing down. So you started running away from home, and as you get further and farther, you get tired, so you start to slow down. And the final graph then is this one here. Similar idea. You start out really fast, your distance is decreasing, but when you get out here, not much change. So you're moving toward home, but slowing down. All right. Now, for the grade 9 course, those first 3 graphs are the important ones. The other 4 are just knowing that if it's not a straight line, it's not a constant velocity or constant rate of change. All right, so unit rate for speed. So how do you determine speed? Remember that speed, if I ask you what speed is, from the signs on the side of the road, it's kilometers per hour. So if we break that into a fraction, That means that you are measuring your distance, which is your kilometers, and dividing it by time, which is your hours. Okay, so that's how you calculate speed. So when we look at the graph that's given, so we've got 3 lines here, I need to determine distance divided by time. Now the nice thing is with this, it doesn't matter what size of triangle I pick. So I'm going to create a triangle. I'm going to pick this point, and I'm going to pick this point. So here we go. So let's assume every 2 spaces is 1 hour. How about we do that? And then we'll go every 2 blocks is 50, so every block is 25. So the triangle I drew, okay, for number 1, so speed equals, so distance is the y-axis, 1, 2, 3, 4 blocks. So we said each one's 25, 25, 50, 75, 100 kilometers. How long did it take? It only took 1 block, which is half an hour. So divided by 1/2 hour, do your math. Line 1 was doing 200 kilometers an hour. Now what happens if you would have picked a different size triangle? So let's say your friend next to you picked that dot and that dot. So their triangle looked like that. Well, let's do the red one then. So speed equals, so in this case, distance 25, 50, 75, 100, 125, 150, 175, 200, 225. Maybe I'm off a little bit, divided by, so they went over 2 blocks roughly, so 2 hours. So that's going to be, divide that by 2. Sorry, it should be 1 hour on the bottom there, right? It's 2 blocks, 1 hour. So that's about 225 kilometers an hour. So I'm off a little bit. So obviously bad example. But what's happened is my line it doesn't line up just perfect. So they should be the same. Let's take a look at another one here. So the second one, let's do this. So I'm looking for points that cross at good points on the grid, so it's easier to read. So for line number 2, my speed is equal to 25, 50, 75, 100, 125, 150. So 150 kilometers, 1 hour, 2 hours, so 2.5 hours. So 150 divided by 2.5 is 60 kilometers per hour. So let's pick another. I want to show you that it does work out. So let's pick that point right there. Let's go 0, 0, and I'll use that triangle. So if I do that speed, let's see if it's a better proof here. 25, 50, 75, 100, 125, 150. So I have 175. That's kilometers divided by 1, 2, 3 hours. And of course, I don't think this is going to work out again for me. No, it's 58, close, 58.3 kilometers an hour. And the reason it's not exact is because we're guessing that those points are exactly on the grid. So we're off a little bit, but it does show that relationship. So you do speed, you create a triangle, all right? So we'll do it below here. To find unit rate. Step 1, draw a triangle. Triangle using the graph as your hypotenuse, the longer side. Step 2, measure height and your base. And step 3, unit rate is equal to height, so your y value, divided by base, which is your x value. And that will always give you your unit rate. So if we look at an EQAO style question, we get a graph that looks like this. So what I'm going to do is I'm going to break this into a second video, and we'll do the last two examples quickly in the next video. So we'll see you in a second.